Hello friends, so today we will discuss that how we can do the dynamic analyze in our Staad Pro. Okay, so first of all I just want to see the model. This is my geometry that I have taken for my practice. Okay, this one. Okay, in the plan you can see this type. The properties I have taken like 0.5 or 0.5 as for column and 0.35, 0.35 for my 0.35 and 0.5 for my column for beam. Okay, now material is concrete, specification there is no need of specification and the fixed support I have taken and let's we start and we continue for loading. Okay. So let's we continue with loading. So in that, how we can, first of all, I want to show that why there is need of the dynamic earthquake analysis. Okay. So let's see that first. So I open the code of our Indian standard. So this is IS 1893 2016. So in that, let's I search first dynamic by this keyword. It will come. Okay. Go down. Yeah, the seven, I think index number seven is for dynamic one. So let's say see where is the index 7, 7.7 I think. Yeah, this one. So here you can see dynamic analysis method. Okay, so when we have to follow the dynamic, if you are building, you can read this first line. Okay, the first passage 7.7.1. By this you will get a very you can say very good idea. Okay. So if you are building, let's say you can just read this one. Other than regular building, lower than 15-meter height in seismic numbers 2. Okay. What is the meaning of that? If your building have like a 1 second, let's I draw here. If there are, because as you know now there are how many zones? 2, 3, 4, and 5. There are 4 zones available in our 1893 code. Okay. So if your seismic zone is 2 and it has a height of the building as less than 15-meter, then you can go with what? Then you can go with only static, means there is no need for the dynamic. But in other case, if you have these things by the red color I am marking, if your building has 15-meter more than 15-meter height in both, in seismic zone 2, but whichever is the height in seismic zone 3, 4, 5, no issue of the height. Okay, there is no issue in the height for seismic zone 3, 4, 5. Then you have to do the dynamic for these cases. Okay. So as you can see in the chart also, as you can see in the map also, let's see that map, this one. So you can see the seismic zone 2 is available at here, is available at here, is available at here. It means in these region, if the building height is less than 15-meter, then you can go with only with static analysis. Okay. But for other type of zones like 3, 4, and 5, you have to take what dynamic. And zone number 2, if the building height is more than 15, then also you have to go for dynamic analysis of earthquake. So that's the meaning of that dynamic. Okay. So there are two way to do the dynamic. If you have done your MTech in structure, then you all know that what are these dynamic and static cases. But I am just giving the idea about that, means how you can do the dynamic. So there are two methods to do the dynamic analysis of earthquake. So first method is time history analysis. Okay. And second method, response spectrum analysis. So in the time history analysis, we will do the analysis of the building for the dynamic earthquake for a particular earthquake parameter. Okay, it means you have the data of the particular earthquake. Then you can do the time history analysis. But for all the earthquake that may be happened in your building after the construction for the for design life. Okay, then you can't do the time history analysis. For that, you can use the response spectrum. And for response spectrum, there are like a response spectra are given according to the type of the soil. Okay. So for three types of soils are there, soft and medium and tough. Tough for you can say the hard soil. So this is for response spectrum analysis. Okay. So these are called as spectra. Okay. So with the help of these SFIG, this is our what? Acceleration spectra. Okay. This is our acceleration spectra and G is our You know, G is our gravity constant. Okay. So these all the things are here. According to the time period of the building, you can calculate this response. Okay. Means the maximum acceleration. Okay. Maximum spectrum analysis. Acceleration is the full name of assay. MSA is called also. MSA means maximum spectrum analysis. Okay. Sorry, acceleration. Okay. Maximum spectrum acceleration. Okay. MSA. So this is our assay. You have to just multiply with these all the values by G. You will get the value of assay. So this is according to the 5% of the damping. Okay. So according to the time period of your building, it will calculate what is the acceleration, peak ground acceleration. Okay. You can say PGA also. So peak ground acceleration, it will calculate from here, and according to that, it will design our building. So it's like a very, you can say it is accurate method like a spectrum, response spectrum method. Okay. So you can use it. So for that, let's say I'm taking my building in Delhi. Okay. So whichever is the height, it's not an issue for dynamic analysis, because if your building is in zone number 3, 4, 5, then there will be not any criteria for the height for dynamic and static analysis. Okay. So you have to do the dynamic for whichever is the height in zone number 3, 4, 5. Okay. So I'm taking the zone. So let's go for first of all definition. One thing that you have to remember, if you are going for dynamic analysis, then you have to do the static as well. Okay. First of all, you have to do the static. After that, you have to do the dynamic. Okay. That thing you have to remember. So in the seismic dimension, you have to just click on add and take your code, go to the generate, and let's say take the zone as 4. And my building is, let's say, RC building with ordinary moment resisting frame. Residential building, let's say I take the medium soil, and my building is RC moment resisting frame. Click on generate, click on add. Now you have to take some self weight, means these are our what? These are our seismic weight. Okay. So how we can define this seismic weight? That also I will cover in this. So I will cover the static analysis as well as dynamic also. Okay. So we'll do it later. Just I am taking the self weight as well. Okay, this thing. Now go for next. Okay, so this thing is clear. Let's go for next. Yeah, so first of all, let's say define some load case. So click on add, and first you can take as earthquake load, because it's the rule of the Staad Pro. You have to define the seismic zone, seismic load prior to other load cases. Earthquake in that, and let's take the dead load also. Next one, let's take live load also. Okay, that's it. Partition wall load also you can use partition wall load PW. That is also like dead load. And let's take the floor finishing as well. Okay, no, there's no effect of that. That's also our dead load. So let's take the floor finishing. So this type of loading case I am taking. Okay. So first of all, go to the earthquake and define it as one. Click on OK, and the Y. Okay. So in the seismic zone, go to the force jet factor as well. Dead load. First of all, the dead load you can take like a sulfate, and take the area load for the sorry, floor load for the slab weight. Okay. Sulfate of the slab. So that's our like a 3.75 approx for 150 mm as. Let's take the height as 30. It is defined. Yes. That is not defined at here. So let's increase the height. Let's delete this story because it's already a very high-res building. It will take the time for processing as well. So let's say deleting some storage, because that will take so much, you can say, processing time for that. So that also the issue for us. Now it is okay. Sulfate you can assign to all, assign to you, and other diode load is our what. So I already defined the partition wall also. So in that we can assign the load of partition wall. Live load you can take, again, let's say I'm taking the floor load. and let's I take the value for example 3. Give the range as 20 meter. Partition wall load you can take. So let's I take the partition wall load as member load and the value is approx 11.25, negative 11.5. I have already calculated these values in my all the lectures. So I have to assign this to all the beams. Okay, parallel to X and parallel to Z. Selected, assign, yes. Floor finishing, you have to again add, go to floor load and let's I take the floor finishing as 1.5. Let's give the range 20. It is already assigned. Let's we go for our forward for our static analysis. So for the static analysis, there are a lot of formulas also in our code. So let's I explain that. One second. I open my tab. Mhm. Let's I open my note. Yeah. Okay. So let's cover all the things. Okay. So there are two ways to do the analysis. First is our static. Second is our dynamic. And when we have to do the static, so there are only one case. Which one? If your zone what? Seismic zone 2 and it has a height as less than 15 meter. It's only the single case. Then you can go only with what? Static analysis. For other cases, like if you have the zone 2, but height is more than 15 meter, then you have to do the dynamic. And for other zone also, you have to do this. Zone 4, third, 4, 5. Okay. So these are the criteria for this. Now let's discuss what are the static, what are the dynamic. Okay. So static, as you already know, there is the formula of VB. Okay. This is our design lateral force is equal to AH into W. AH is our coefficient. Okay. Design horizontal coefficient. And this is our seismic weight. So what is the seismic weight? So seismic weight is already, you can define, it's our 100% of the dead load and some percentage. So I am taking the L, X. Okay. Let's take the value of X. So this is the formula of my what? Uh, this is the formula of seismic weight. You can learn it also. It's very easy. Now, what is the value of X? So X is what? X is 25% forward live load less than and equal to 3 kilonewton per meter square. Okay. And X is equal to 50% for other case. For what? Live load more than 3 kilonewton per meter square. So these are two formulas that you have to remember. Okay. So two criteria for live load. According to that, you can decide the value of X. Now, which is force it will contain? Mean dead load which force is contained like self weight of all the members, self weight of beam, column, slab. Now, other thing is what? Self weight of brick wall also, like partition wall load. So that's also your dead load part. Okay. Floor finishing as well. Okay, so these all the things are considered in what? Considered in our dead load. And live load you can just assign according to the code of IS 875 part 3. That's it, part 2. That depends on the type of the building and type of the room. Now what is the AH? So this is our just a coefficient, okay. And the formula of AH is also given in the code. So let's I return that Z by 2 SA by G and R by I. So this is the formula. Z is our zone factor. SA by G our spectrum, okay. You can calculate what? PGA. Peak ground acceleration with the help of SA by G plot. Okay. And R by I, R means your response reduction factor, I is your importance factor. So you can just given these values in which, because we are already given this value in where, so we have given this all the values like in our stat in this definition. If you double click on that, you have given the zone factor, response reduction factor, importance factor, site, okay, type, damping ratio. These all the things you have given here, okay. These all the things you have given here, as you can see. Yeah, there is one thing also. Let's I focus over that. So if I click on run data again, let's I do all the things again, okay. Medium soil and okay, purple. Now here you can see the period, the time period also you have to give. So how you can calculate these periods? So there is the formula of these periods, okay. So let's I show that also. Time period for all the type of the structure. So time period for all this type of the structure that is also given in the code, I think in below. One second. Let's I open that. Okay, Z by 2 and these are the irregularities, importance factor, reduction factor. These are the table, okay. For up to 3 kilonewton per meter square, you have to take 20% imposed load. Imposed load means your level, okay. So that thing is given here. Yeah, so there are the equivalent static method that I am going to discuss. Okay, static method, or you can say equivalent static method. This is the formula AH into W and the time period that you can calculate if there is not any masonry infill. But in our case, there is the infill walls. So according to the type of the structure, you can use this formula. Okay, TA and these all the thing. Not any structural walls, and for other building you can use this one. So we have to use this one for calculating the time period. Okay. So what it D? D is our base dimension of the width at the plinth level along the considering direction of the earthquake. So for X also you have to define, for Z also you have to define. Okay. So let's calculate this one. So let's I first write this formula in my case here. So the formula of the time period, that is our 0.09 H by under root T. So let's calculate for X and calculate for Z. So 0.09 height is again same. So let's I check the height. What is the height of our building? So let's I first check the height. So how, yeah, the 3 meter, 3 meter, 3 meter, 3 meter, 3 meter. 1, 2, 3, 4, 5. So it is 15 meter in the height. And what is the length? So that also I have to check. Okay. Let's I click on generate, click on modify, close. Okay. So let's say check the all the things. So you can go to the utilities, go to the beam tools and node to node distance. So from here to here, this is along what? This is along my X. Okay, so 24. Along X that is 24 and along my along Z that level 36. Okay, 24 and 36. Click on escape and go for entering the value. So 24, height is 15 meter, 40 Z, 36 I think. Let's say check again. Yeah, 36 and 24. So Z 36, X 24. Oh, one second, one second. This is not, it's same 15. So if you calculate these values, then you will get the time period. So let's I calculate this one second in my calculator. Also can calculate these values. Just a minute. 0.09 into 15 divisible by under root of 24. So that's come out as 0.2755. So this is our second. Okay. Let's calculate this one. Under root of 36. 0.255. 225. Just you have to enter these values. Okay, in that time period box. 0.2755. So let's say I double click on that. So this is our, you have to again go to this one. Let's I change this also. Residential, medium, period in X, 0.2755, period in Z, 0.225. Generate. That's it. Okay. Here are also given. Just click on modify. Now we have defined our what? Which section we have defined? We have defined our this formula. Okay. Means the formula criteria. This one. So this thing we have defined. We have defined Z, we have defined SA by Z, we have defined R by A. Now we have to define what W. Because A is now complete. Now we have to define W. In W, you have to first of all add the dead load and add the live load also according to the value of live load. So you have to take the percentage of that. So that's how you can do that. So just click on this also. Okay, in this also you have to assign the all the things. So sulfate is what? So I have already taken the sulfate. But sulfate of what? Sulfate of beam is taken, sulfate of column is taken. Now you have to take what? You have to take the slab, pre-pole and floor finishing. Just you have to add this. So first of all, take all the dead loads. So beam column are already formed at here. Okay. So that's why in sulfate one, it will automatically take. Let's add for slab also. So that is our floor weight. What is the value? 3.75 for 150 mm of the thickness of the wall. Thickness of the floor. Okay. Slab. Height is you can take it as up to 20. Add this. Now other thing is what? Slab sulfate is done. Now brick wall. So brick wall load also you have to take. So that's in our member weight as uniformly distributed. So that's value is 11 to 11.25 you have taken. There is no need of taken the positive negative. Okay. We have to just define the formula parameter. There is no need to do that. And floor finishing load also we have to take. So click on again add. And I have taken the floor finishing as floor load of 1.5 to the range. Now, just you have to assign this because it is our question mark. So assign to all the beams. Select co, assign and property by the property. Select beams. Sorry, this one. Assign to selected. Assign yes. So it is assigned. So in this way you can assign. Now what we have assigned now. Beam also we have assigned. Means this will come in our what? This will come in our sulfate 1. Slab weight I have taken what? 3.75 kilonewton per meter square. Brick wall 11.25 kilonewton per meter square. Floor finishing that is our 1.5. So I have assigned all the you can say that load. Now we have to assign the live load according to the value of what? Value of live load. So what is the value I have taken? So I have taken the live load. So let's you can check in live load also. 3. 3 will be come in our what? Which table? So 3 means equal to 3 is. So you have to take 25% of the live load. Live load means 3. Okay. Whatever is the value, you have to just take the X% according to the live load values. Okay. So 25% of the 3 you have to taken in our seismic weight. So 25% into 3. It means you have to divide by 4. So it will come out as 0.75 kilonewton per meter square. So that also you have to assign. So again you have to go to the zone 1. This one. Again add. So that is our floor. 0.75. Don't consider any sign. Okay. Just take all the positive. So now in this way you can assign your all the static parameter. Static, okay, or parameter, okay. Now you have to assign what? Now you have to assign your dynamic parameter. So how you can assign dynamic? So for that also you have to do some work. Okay. So how you can assign that thing? So let's go for that. So in the load case, and first of all you have to define your mass. Okay, model mass. So let's define that. Go to the loading and click on mass model generator. Now, these all the things are here. Okay. New reference load case. Okay. Just click on it. Generate. It will automatically generate all the loads cases that are required for your case. Okay. So these are our model mass in all the direction X, Y, Z. Okay. So the model mass is generated. Now you have to just go for the response case load case detail. Click on add. Now define your response spectrum means spectrum analysis. Sorry, one second. Spectrum. So define in X also. So in that you have to use what? You have to use mass. Click on add. Now take the next one. Spec Z. Now click on add. Now you have to add those all the masses also from here. These all the things you have to add and this also. Okay, 4x. Only 4x also. Okay. So I will add this. One second. Just wait for some time. There is one code. Please wait for 1 minute. Okay. So yeah, we have defined these all the load cases. Okay. These are our masses. You can say these are our seismic weights. Okay. In all the direction. Lumped mass system. I think you have heard this word. Lumped mass system. I have also covered this thing in my last of the lectures. Okay. You can check from there. So the name is what? Lumped mass system. Let's define dynamic earthquake. So for that you have to add these all the things in this also, in this also. How you can do that? Just go for let's say define anyone, okay. And you can go with the command file also where you can do these changes. So go down and numbers incidents. Okay. Yeah. So define material property and reference load. This one. Now just select here to here. Okay. Up to here. Just press Control C and paste this one in this also and paste this one in this also. That's it. Click on Control S, select, save it, cross. Now you have to define your response spectra. Okay, I have taken my all the load case in that. For now, you have to just define response spectra. So for that, click on spec X, go to the add and in Sismic, not this one. Response spectra you have to take. So first of all, you have to choose your code. 1893 Part 1 2016. You can use SRSS for the combination, model combinations. Now, you have to consider what? You have to consider X direction. Okay. Acceleration, linear, damping is this. Soil type, you can take the medium. So this is your, you can say what? This is your, the spectra. Okay. You can say this is your spectra. So, yeah, that's it. There is nothing, nor the model partition is not center, not a problem. Okay. So you have to just add this for X. Now, add this also for your Y. Choose code, medium soil I have taken for Z, sorry, not for Y, for Z. Now these are added. Okay. So you can see these all the things now added here. Okay. Let's because it is now take some time in process. Okay. So we have to take load factor. Let I show that because we have to add the inputs also in this. Which one? This one. So that now just a minute. That's a following the style. It will take a lot of time in this type of things. Just a minute, okay. So this value also we have to enter, okay, in the direction that are the factors, okay, scale factor you can say 4x. So how you can calculate this value, okay? So that's a simple value, okay. What is the scale factor? The scale factor is just about you can say like a z by 2 multiplied by r by 8. This is the factor. So you have to calculate this one and enter this value at there. So what is that? So z is our is 0.24 for zone number 4. R is 3, I think. We have taken the response reduction factor as 3. And what is I? I is our 0. Sorry, that is our, I think, 1.2. Yeah, I think 1.2. So that you can calculate. This is our, one second. So if you calculate, this is our 1.0.122 or this is our 0.1, I think. Let's I calculate. One second. Sorry, it's divided. Sorry. It is divided because the formula is z by 2 SA by G upon R by 8. So that's why you have to take this one. Okay. So z by 2 means 0.24. 2 divided by R is our 3 and 1.2. It means it is our formula what? You can do just the reverse of that. So z by 2 into I by R. So this is the formula for this scale factor. So you have to do just only this. So it's our like so you can calculate it. So that will be come out. I will let's say calculate that one. Multiply by 2, 0.12 and divided by 3. So that's come out as 0.048 for both the direction. Okay, that depend on the direction. That don't depend on the direction because for x also the formula is same. For z also the formula is same. For y also the formula is same. So it means you have to take this value 0.048 at there. So you have to enter this value. Click on modify. Click on yes. Close it. Now remember one thing. Uh, let's just load it. Remember one thing because there is no need to assign this model mass in both of the spectrum analysis load cases. Okay. If you define in anyone, like I have defined these all the things in load case 7, that's also my spectrum. So there is no need to assign this at here. Okay. So you have to just you can do just delete it from here by the command file. So let's say delete this one because it will show the warning after that. After the analysis, it will show the warning because there is no need to assign these things a number of them. Load case 8. So in that you don't, there is no need to assign this thing. Click on Control S. And I change the factor also because the factor is same for both of the direction 0.048. So press Control C and assign it here. Press Control S, save it, cross it, and one second, let's load it. Yeah. So now it is assigned at here also. This is 0.048, the same value. Okay. So in this way, you can do your dynamic as well and static as well. Okay. So you have to do the static also if you are doing the dynamic. Okay. It's a compulsory that if you are going for the dynamic analysis of any type of the load, like wind also, that is also our earthquake also. Okay. So you have to do the dynamic static first before the dynamic. That's the rule of the this load assignment. Okay. You can do your all the dynamic analysis. Okay. So these are the spectrum Z, this is spectrum X. So we have done our what? We have done our static as well. So this is our static. This is our static and this is also our static. What is our dynamic? So dynamic is this response loads and this one. So these are our in X and these are in our Z. So in this way you can do your static as well and dynamic as well. So thank you friends. Let's meet in next lecture.